about the photoelectric effect. Explanation. Okay. Photoelectric effect. When light is shone on a metal plate, electrons can be emitted. The conditions that determine whether electrons are emitted or not tells us a lot about the nature of light itself. Threshold frequency. Electrons are only emitted from a metal when the light hitting it is above a certain frequency. Below this, no electrons are emitted. This frequency is called the threshold frequency. This is different for every metal. So basically, for electrons to be emitted, it has to be above the threshold frequency. Kinetic energy variation. The maximum kinetic energy of an emitted electron is dependent on the frequency of radiation, but no intensity. And above the threshold frequency, when the light, electromagnetic radiation, is above the threshold frequency of the metal, the number of electrons emitted is proportional to the intensity of the light. So, which of these statements about the photoelectric effect are true? Maximum energy depends on intensity or frequency. Ooh. When light is shone on a metal plate, electrons can be emitted. Electrons are only emitted from a metal when the light hitting it is above a certain frequency. This is called the threshold frequency, not surplus. Idiot. Okay. Failure of wave theory. Wave theory wasn't able to account for the photoelectric effect. Intensity independence. According to the wave theory of light, the intensity should determine the energy transferred to the electron each second. So we'd expect the maximum kinetic energy of emitted electrons would increase with intensity, not frequency. Threshold frequency. According to the wave theory of light, energy should be spread out evenly, but it's not spread out evenly. So explain why the existence of threshold frequency and the photoelectric effect prove that the light was not a wave. Go. This is because light should be spread out evenly across metals, but the energy is absorbed by each electron and would gradually increase. So after a while, the electrons would not have enough energy to be emitted. Increasing the intensity to a very high level had no effect on the electrons, thus it's not a wave. According to the photon theory of light, it's not the photon theory of light, it's a wave theory of light. Wave theory of light. Energy should be spread out evenly, but it's not. What is the name of the minimum frequency threshold? That's a terrible attempt at spelling it. Threshold frequency. That was a bit better. Explain why the maximum kinetic energy of emitted electrons being interdependent of intensity in the photoelectric effect provides evidence that light is not a wave. Well, energy is not evenly spread out. Yep. Basically, there are the rest of them that you need to know, but like the basic, simple, sweet 1 mark answer is energy is not spread out. So it's just disappointing, really. So, now there is an explanation. So Einstein came up with an explanation of the photoelectric effect. He suggested that waves were made out of little packets of energy called photons. So each photon had one-to-one interactions with electrons. The electrons would absorb all the energy of one photon. This explained why the maximum kinetic energy is independent of the intensity. Intensity is the number of photons per second. It doesn't matter how many photons arrive per second, because electrons only interact with one. So imagine electrons are the chick and photons are the man. So energy depends on frequency. Einstein also suggested that energy of a photon is proportional to its frequency. The relationship is this. So E equals h over f, so energy equals Planck's constant times frequency, or in this case frequency, as we know, wave speed equals frequency times lambda, which is wavelength. So in this case here, it would be Planck's constant times wave speed over wavelength. Simple. This explains why the maximum kinetic energy of the emitted electrons is proportional to the frequency. Boom. So, what's the energy of a photon with a frequency of 3 and Planck's constant of that? So, HF, that's 3, that's 19 point something. Let me do the maths. Definitely not reaching for a calculator. I have definitely not done anything at all. Racist. It is. Is it not? 6.63 times 3 is 19. I'll give your answer in electron volts. Well, first of all, in joules, it's 19.9. 19.20. Well, what do you want from me, man? What do you want from me? Substitute the values in. Yeah, 6.63 times 10 to the minus 34 times 3 times 10 to the 15 is 1.99. Oh, I was being an idiot. Basically, our physics teacher was like, in physics, never do standard form the way you're meant to do standard form unless you're giving an answer. So convert to electron volts, so that's 1.6. So 1.99 divided by 1.6, 0.99 divided by 1.6 is 1.24. Oh yeah, I should probably mention that to convert from joules to electron volt, you divide by 1.6 times 10 to the minus 19. So that should be... Oh yeah, I have to actually incorporate units because units aren't the same in this one. And that is divided by 1.6 times 10 to the minus 19. Simple. And that is 1.24. 12.4. Okay. I was going to write in standard form. In the photoelectric effect, each photon has a one-on-one interaction with an electron. How does this explain the maximum kinetic energy? It's basically because it only interacts with one electron, not all of the electrons. So it doesn't matter how many photons arrive per second. So the consequences of the photon model. Einstein's photon model helps explain the photoelectric effect. Work function. For an electron to leave a metal surface, it has to overcome the bonds holding it down. The energy needed to break these bonds is called the work function. The work function is different for metals. Threshold frequency. We can use a threshold frequency to work out the work function of a particular metal and vice versa. So the threshold frequency is the energy times frequency, but there is no kinetic energy involved in it. Photoelectric equation. So that is the photoelectric equation. So the total energy is Planck's constant times frequency, which will give the energy, and that will be plus the kinetic energy, and kinetic energy is obviously half mass times velocity squared. And stopping potential. Measuring the stopping potential can help us work out the maximum kinetic energy. After the electrons are emitted, they pass through an electric potential. As the electrons are charged, they must do work to move, thus there is kinetic energy. Which quality is denoted by the symbol joules? So that is energy. It is energy. It is like total energy of the wave. I think like I said, threshold frequency or some garbage. But that one's kinetic energy, a work function, which is the same thing as joules. Work function. So photon something is equal to Planck's constant times something, which can be written as Planck's constant times the speed of light divided by wavelength. So photon energy is equal to Planck's constant times frequency. Simple. Skip the video. For an electron to leave a metal surface, it needs to overcome the bounds holding it down. The energy needed to break these bounds is called the work function. The work function is different for different metals. Planck's constant is multiplied by the frequency of the incoming photons. Simple. And now the end of topic test for this. So we've basically learned the photoelectric effect we've learned it in 10 minutes. Now topic test. What term describes the emission of electrons from metals that are shone with light of a certain frequency? Photon. What term describes the emission of electrons from metals that is shone with a light? I wonder if it's gonna be the photoelectric effect. Oh no, who would have thought? No way. Which of these statements are true? The number of electrons is proportional to frequency. I don't think it is. All metals have different threshold frequencies, yes. Maximum kinetic energy depends on its intensity. All metals, no they don't. Maximum kinetic energy depends on frequency, yes. And the number of electrons is proportional. Is electrons proportional to the frequency or the intensity? Intensity, because only one electron can go with each photon, so no. What theory of light does not explain the photoelectric theory? Wave theory. According to the wave theory of light, what should the maximum kinetic energy of emitted particles be proportional to? It should be proportional to intensity. I wrote frequency and then gave up. Who proposed the proton theory of light? Einstein. Genius. Yeah, why do you have this picture? What symbol denotes Planck's constant is H? It's a special demented looking H. So, which of these equations for the threshold frequency is in terms of the work function? The work function is the O, and so O equals F times H. That means that F equals O over H. Yep, that one. What term is given to the energy needed to break it free from bonds in the metal? Threshold frequency. My spelling really doesn't help with this, does it? What process involves an electron being completely removed from an atom? Wonder what? Well, ionization does. But that's like chemistry, really. What does the electron absorb in order to move up energy levels? Electromagnetic. It's not radiation, is it? It's electromagnetic waves, really, is it not? Nothing? I swear it is. So no electromagnetic waves? I think it might be. The answer was light or photons. What are the two substances in fluorescent light? The two substances in fluorescent light. Electrons. Nope. Photons. Nope. What are in fluorescent light? Why do we care? Like, that was not mentioned. Fluorescent is a mix of argon and mercury. Argon, apparently. Nope. Noble gases. Nope. Let's see what it is. Mercury and phosphor. Oh look, where does it say phosphor there? It doesn't. When was that mentioned? What kind of photon does de-exciting electrons in mercury vapor emit? UV. Yeah. It's the one that's closest to it. How do you convert from volts to joules? Or electron volts to joules is 1.6. I think it was 1.67 exactly, but thank you, I appreciate it. This is done.